Welcome back to today's Explainer. We're officially on day 10 of our code review journey. And look, today we're tackling one of the absolute highest stakes missions in software development, performance. We're here to make sure your code doesn't just walk, it literally sprints. So, the overarching goal of our curriculum today is a total fundamental shift in perspective. When we review code, it is just so incredibly easy to fall into the trap of only verifying functionality, like, hey, the code works, the feature is shipped, the bug is fixed, let's hit approve, right? Well, wrong. Today's mission is all about shifting that mindset from merely making the code work to fiercely protecting our system's speed and efficiency. We've got to look at the code base not just as a static set of instructions, but as a living, breathing system where literally every single millisecond counts. Part 1. Detecting the usual suspects. Let's dive right into this lineup and identify the exact repeat offenders we need to catch during our reviews. Picture this for a second. You open up a pull request to review a colleague's code, or, hey, maybe even your own from a few days ago. The logic seems sound, the variable names are clean, it even passes all the tests. But what specific bottlenecks are hiding right there in plain sight, just quietly waiting to absolutely murder your performance when it hits production? Well, our source material gives us a highly specific, 4-point hit list to track down. We're talking nested loops, N+1 queries, unnecessary API calls, and repeated calculations. Let's break down exactly why these 4 made the hit list. First up on our radar, suspect number 1, nested loops. This is a classic trap. The real threat here is exponential scaling. A simple single loop? Totally fine. But nesting them inside each other creates this gnarly O of n squared trap that basically multiplies the work your code has to do with every single iteration. Sure, a few nested iterations might run perfectly fine in your local dev environment, but scale that up to 10,000 users, and you'll completely freeze a production server. Spotting these early is absolutely crucial. Next up, we have N+1 queries. I like to call these the silent database assassins. Instead of grabbing everything in one efficient swoop, your code ends up fetching data one agonizing row at a time. And honestly, if you're using an ORM, these are notoriously easy to accidentally approve unless you are actively, specifically hunting for them. The third culprit to keep an eye out for is unnecessary API calls. Reaching out across the network introduces massive, totally unpredictable latency. Making these calls when you don't need to, or, forgetting to cache the results, literally holds your application hostage while it waits on an external server. It's basically like building speed bumps right into a Formula 1 racetrack. And finally, suspect number 4, repeated calculations. Think about it. Why force the CPU to execute some complex string manipulation or super heavy math 50 times when you can just compute it once, assign it to a variable, and reference it? It's all about finding exactly where your code is burning up unnecessary cycles and putting a stop to it. Part 2. Practicing time complexity analysis. Now that we know who we're hunting, let's translate all of this into our actual practice. So, we know what the suspects look like, but how do we actually prove they're guilty in the real world? Identifying them is really just step 1. We need an objective methodology to measure a bottleneck's potential damage long before it ever scales. And that brings us to our core practice for day 10, analyzing time complexity. This is the practical tool we use to evaluate exactly how our code's runtime scales as our data inevitably grows. When you spot one of those suspects, you really must ask the hard mathematical questions. If the input data doubles, does the execution time double? Does it quadruple? Or does it just flatline? This right here is the crucial shift. We are moving from just hoping your code runs fast to actively practicing time complexity analysis to mathematically prove that it's optimal. Listen, hope is not a valid engineering strategy. You don't just cross your fingers and deploy to production, right? You catch that exponential scaling during the code review. Our source text leaves us with this incredibly focused, direct mandate. Practice analyzing time complexity. Notice it doesn't say think about time complexity. It says practice. It's an active verb. You have to hone your detective skills on every single code review. Every time you look at loops or database calls, API requests, heavy computations, you need to be actively running that mental math. As we wrap up today's explainer, I want to leave you with a challenge for your very next pull request. Don't just check the syntax. Hunt down those N+1 queries. Completely kill the nested loops. Ask yourself, when you click approve today, what will your time complexity reveal? Is it a system ready to scale beautifully or just a bottleneck waiting to happen? The choice is absolutely yours.